Hello engineers and welcome back to the DevSecOps series. So today we are going to learn about what are the different principles that we get to see in DevSecOps. So as you already know that we are discussing about security as a shared responsibility from the beginning. Shared responsibility between whom? The development, operations and the security team. So once they are together, they should be thinking about how to secure the entire SDLC that they are supposed to follow. So let's see quickly what are the different topics we will be discussing in our today's video. So you have already heard about this particular term a lot of times in our previous videos, shift left. So this is the very important stuff that we are going to deal with. Okay. Then comes the security governance. What is meant by governance in terms of security? We will be studying today. Then what are the different facets of risk management? What is it? And the different types we will be seeing. Sorry. So then comes what is automation, and then what are the different security tools that we have to integrate. So automation of what? This is what we will study, and then again what kind of tools are to be integrated at what different phases of the SDLC. Then comes continuous monitoring and feedback loops. So let's begin with these different topics and see in depth today what we really mean by the principles of DevSecOps. So before we discuss about what is shift left, let's first discuss about what is software development phases. What are the different phases or the stages that we go through when we are talking about developing a software, entire product. Okay. So here you can see few phases that I have listed out. First is the requirement analysis. Now, before we even try to begin with the development process, we need to know what kind of software we have to build. Now, what technologies are to be used while building that thing. This is what we need to first gather in this particular phase, which is called as the requirement analysis. These are the different functionalities that I want my software to have. Okay, this will be beneficial for our customers, or like this is the general thing that we used to think about while gathering any requirements. Then comes the design. Okay, so how my application should be designed. Okay, either it is a on-premise application or a cloud application, either it is a multi-tenant or a single tenant application. Will this particular application will be working on a mobile phone or a computer or a different server. Okay, this is what we have to think about while we are in the designing phase. Okay, so basic architecture of the software, what machines it would work on, how the users will access these things. This is what we are going to decide in the design phase. Then how are we supposed to implement this? Okay, what tech stacks to be included? Okay, is it a 3-tier application, a 2-tier application? How database is to be configured. This is what we will be thinking in the implementation phase. Okay, how are we supposed to implement that particular technology stack for building this product. Then comes the part where after we have decided the tech stack, we will be starting the coding journey. So this is majorly done by the development teams that we get to see. So development teams will collaborate with the security, not the security, but the solution architects, and then will iteratively work on the building of this application. Then next is the testing phase. Once the development team have created their code, or like let's say a code base or a project, then comes the testing team where they'll check the functionality of what you development team have built. Okay, if it is working as per the expectations that we have set in the requirement analysis, and if it works fine, then it's all okay. Otherwise, raise a ticket which would describe that this is a bug. Okay, bug is something which they think that okay, this should be working in a different way, but currently it is not behaving as per the requirement. So this is a bug. It is something which is not working right. So that is called as a bug, which we find out in the testing phases. So majorly quality assurance people are working in these phases. Okay, They can do manual testing or automated testing and a lot of different stuff. Then next is the deployment of the application on any cloud infrastructure or whatever the systems that we are trying to build. Okay, so deployment is one, and then once the application is deployed, you have to check if it is running smoothly on those particular like environments. So that is where we go into the maintenance phase, wherein we have to see if the CPU is not being overworked or overloaded with the tasks that are running in the background, and like a lot of different things goes into monitoring phases. So that is the maintenance part. Now again, iteratively we go back to the requirement analysis and do the stuff again and again. So this is a continuous loop that you might have heard about, this infinity loop. Okay, design, then implement, coding, testing, deployment, maintenance, then again requirement gathering, enhancement requests are there. So this is how your software will grow in its size and applicability. So now in all these particular previous phases, we never encountered about security testing. Where is security in all of this? We are just only looking at how the application will look like, or what are the different functionalities, or what things goes into the coding architecture, but nothing about security has been discussed till now. So once the application is deployed, then if some attackers attack on the application, then only we are concerned about the security, like, oh, my application is getting attacked, how do I secure my data or the user's data and prevent the attacker from stealing some sensitive information. So this is what we think in the very end of our SDLC. So to avoid that, we introduce something which is called a shift left. So shift left, it means all these things. Let's just delete this mess. Okay, all these things that we have discussed here, security comes at the very end. Okay, it comes at the very end after the maintenance phase is there. So what we want is to think about security from the beginning. Okay, that is why we call it as security. Instead of getting to think about it over here, we will be thinking it before the deployment phase. Then before the deployment phase, what comes is testing phase. So we will again try to shift left and think where in the testing phase I can implement some stuff which would secure my product overall. What is this posture, security posture of my application or my infrastructure. So where in coding I can apply some measures which would help me to mitigate some security risk beforehand. So this is what we call as shift left. And the term shift left here refers to the idea of moving security testing, okay, including security testing and analysis earlier in the development process. So right from the requirement analysis or the design phase is what we want to implement security, so that our overhead of managing security vulnerabilities or exposures later on, once our application is deployed, should be less. So anything which is done later will be very expensive, and a lot of threat would be there or risk would be there to do those stuff. So that's why shift left is really important, to do something beforehand. So it encourages developers to consider security issues from the beginning of the development process rather than waiting until the end. So this is just about anything that you see. Let's say you want to secure your home. So rather than thinking about applying the locks at the end of your home is created and all this thing, or house are created, we first try to install the door so that no one could steal away anything from your houses. So this is the same thinking that goes behind it. So now, what are the different things that we can do in order to secure or shift left our security in this SDLC? So in the requirements analysis and design phase, we can implement something which is called as a threat modeling. So we will be discussing about all these things. What does it mean? Okay, what is threat modeling? what is tried, what is pasta, what is dread. These kind of terminologies which are associated with threat modeling, we will be discussing about in our further topics. So just today we will be discussing about what things we can apply in which phases. Okay, then implementation and coding phase, we can apply SAST, SCA. Then code review can be done, because coding is a part of this phase, so code reviews are must. Some intern will write some code, unless it is reviewed or verified by some senior, it is very dangerous to put that code in production. Something like CrowdStrike would happen then if you know what I mean by that. So next is container security. If the application is containerized application, then we will look into it. Then CI/CD, continuous integration and continuous delivery or deployment modules, and then securing those modules. Secret management, a lot of secrets are being used, API tokens or pass keys, secret keys, IDs, access keys are used on these days instead of using username and password. So managing those secrets is a huge task which we can include in this particular phase. Then IDE plugins are what we can use while the development team is under coding, and they can get the findings out of it, like this thing is vulnerable or not, like that. So IDE plugins can be also used. So these are the different measures we can include in these phases. Then in testing and validation phase is what we can apply DAST and IAC, infrastructure as code and configuration management security. Because DAST would be when the application is let's say pre-prod environment. We have deployed it on cloud environments, but it is pre-prod, not the actual production environment. So in that phase we can do what is called as dynamic application security testing, and if this infrastructure is safe as well. So for that we will use IAC tools, IAC scanners, infrastructure as code scanners, and configuration management tools, security tools. Then comes the deployment and operations phase. Once the application is live on the production environment, what we can do is we can integrate something which is called as IAST, interactive application security testing tools, then RASP tools, runtime application self protection tools. Then we can apply firewalls, web application firewalls. We can make some alerts and some triggers to mitigate some issues, which we can say as CM, security incident and event management. Then we can do some pen testing once the application is deployed on an environment, and we can also look into the cloud security. Okay, if it is a cloud based application, cloud native application, or if it is an on-premise application, then we can look about the infrastructure security. So these are the different things we can include in our activities when we talk about the SDLCs, security stuff we can add. So this is what majorly asked in the interviews, that in which phase what tools you would apply. So this is what is really important. You can take the screenshot of this particular slide, or download this PPT and save this, keep this entirely in your mind. It will be rather helpful for you in your interviews. Then next is security governance. Now what is this governance? Governance means to govern something, look at some different stuff, and how to look is what this particular thing will tell about. Now the framework and processes that ensure that an organization's information security strategy aligns with its business objective. Okay, this is important. The business objective that you have created and the security strategy, information security strategy, they should align and comply with relevant laws and regulation. So governance is what? Looking at an organization's objectives. Okay, let's say I am creating a application which would be fostering payments from one bank to the another bank. So what is my business objective? Payment interface. Then securing the data of the people should be a priority, because if bank account details are leaked, then that is a really harmful stuff in terms of financial losses that we can procure out of it. So security strategy, and then this business objective and the security strategy should comply with the regulatory laws, or let's say regulations, that are for these nations or whatever the countries that your software is being deployed to. So that's why security governance frameworks or these processes are really important for us to know. Now what happens in that, there are some policies or procedures or structures that guide how security is managed and enforced within our organization. So this is what we kind of know as governance. G, then R is risk, and C is compliance, GRC. This is a trio of like any security governance or risk analysis or compliance stuff. So it is really important that you should know, and when you integrate these different tools at different phases, you are taking into consideration these steps. How much risk is there, risk assessment is what you have to do. Then is this particular application complying to the regulatory body? These are the different things that you get as an insight by using these different tools. Then next comes is key components and principles of the security governance. So let's first discuss about what are the different principles, and then we'll talk about the components. First is that I mentioned is alignment with the business objective. This is really important, because if you fail to create any payment gateway or payment application, then what was the thing of creating this particular company or an organization? You entirely failed at creating that stuff. So that's why the business objective should be the very first priority of why you are doing something and what your product is going to offer to the customers. This is what the very first objective that you need to keep in mind. Then accountability. If you have created that particular application and it is behaving in a way that it should be, then it is okay. But if not, then who is accountable to that? If someone lost his or her money due to your application, then who is accountable to that? If it is the fault of the individual, then it's okay. But if he has done everything right, then who is to be blamed? Okay. Then accountability is also one stuff that you need to think about governance. Then transparency. Whatever you are building, whatever kind of the functionality or the application you are building, everything should be transparent with the regulatory bodies. If not, then they can either sue you or fine you. A lot of things, legal issues, implications can be there if you do not maintain any kind of transparency in this thing. So there is something which is called as SBOM, which we will be later discussing about in our further series. This is really important these days to foster transparency between the organizations and the regulatory bodies. So SBOM is nothing but a software bill of material, and what does it exist is whatever the third party tools or libraries you have used to build your application, this is what it contains. Okay, it is a file, a JSON file containing this information. So in a way you get to become transparent with the customers or the regulatory bodies, and they can know these are the components included in your application, and okay, it is safe or it is not safe, like that. Then a proactive approach is always necessary in doing whatever you do, even anything. Then integration of what? Security tools okay, or the governance tools. That is what is one stuff again. Now let's look at the different components that we get to see in the security governance stuff. First is the policy and standard that you need to set. Then the risk management. Okay, let's talk about policy and standard first. So as I mentioned, there are some regulatory bodies. They have created certain regulations or rule set that you need to adhere to. So these, deriving from these rule sets, you can create some policies and standards in your organization which the teams should be following. Not should, they must be following, so that your company doesn't get any legal notices. Okay, that's why policies and standards, creating them is really important on an organizational level, not just for one team or two teams. It should be for all the team across the organizations. Then the risk management. So Whenever you are developing an application, you should know how much risk does it contain. Let's say you are creating an application which is going to be controlling the throttle response of the aeroplane. So that is really risky in terms of the lives of the passengers that are going to be onboarded on that plane. So if that is not done well within the regulatory or compliance bodies, then it is a really risky stuff. You are playing with the lives of people. That's why adhering to these policies and standards is really important to manage the risk as well. We will be discussing about risk management in great detail in further videos as well. Don't worry about it. Next is roles and responsibilities. You need to know, like, development team has this role. They need to create this functionality in a seamless way. You need to know the operations team have this particular role. They have to deploy and maintain or operate this particular infrastructure where the application is running. Security team has its own roles and responsibilities. They need to look into both of the aspects and try to integrate some tools which would provide security to all of these things. So segregating the rules and responsibilities are the major stuff that you need to look into in the governance stuff, not just in terms of the teams or the people, but the application itself. Then next is compliance management. As we have discussed, that we have to comply to different bodies or different frameworks. So we will be talking about what are the different frameworks available in the industry, or what are the standards. You have heard about FedRAMP, NIST, ISO, GDPR, a lot of different things. So these are the frameworks that we have to comply to. Then next is security frameworks. NIST is kind of releasing some risk management framework, then cyber security framework, then application security frameworks. A lot of security frameworks are there, and you should be depending on the region that you are kind of building your software for, you need to adhere to these frameworks. And so far it is a general good practice that if you follow a security framework, then there is very less chance of your application getting exploited by any threat actors. So that is important. Then what are the different performance metrics? How well your application is working, what is the latency, what is the security score of your application. These kind of performance metrics are also being considered. So something called as KPIs, key performance index, is what you can think about in terms of this. Then incident management. Let's say someone attacked you, that is an incident. Now how do you handle it? That is the part of management. Once incident is there, you need to know how to handle it, or how to resolve it, or how to incorporate some measures that this kind of incident should not be occurring in the near future. So that is what we kind of talk about in the incident management stuff. Then stakeholder engagement. So your customers, your partners should be involved. The government agencies, if your application is dealing with critical data, then these kind of different stakeholders should be incorporated in the discussion of your application strategies and governance strategies. So that's why engagement of these people is really important. Now the next principle is about risk management. So as I told you in the previous slide that we will be discussing a bit about risk management. So here it goes. Risk management is a systematic process for what? For identifying, assessing and mitigating risk. Okay, first is to identify, then assess what kind of different risks are there, and then now try to mitigate or reduce those risks. So that could potentially, mitigating risks. Okay, what kind of risk that could potentially impact on the organization's ability to achieve its objective. So if something is there which is not letting you make any payments by using your application, then what? It is a potential impact on the organization's objective. Okay, so we have to incorporate certain processes to do this stuff. What is this? Risk assessment, identifying and mitigation. So now risk management focuses on protecting the confidentiality, integrity and availability of information assets. So if you have lately heard about CIA triad. Okay, so I was talking about CIA triad. So if you have heard about this, confidentiality of the application, then integrity, no one should be able to alter the data set that you have, and the availability, The application should be all time available and responding to the requests that customers are sending. And the confidentiality, I missed to explain, it is secrecy or protecting your data from unauthorized access. So these are the different things: confidentiality, integrity, and availability. We will be discussing this in great depth in a later episode as well. So a lot of things to cover. That's why DevSecOps sometimes feel like a bit tricky or hard to people, because there are a lot of different things that we have to learn. So as I mentioned, risk management frameworks would focus on these particular aspects of the application or the information assets we have in our organization. Then next is, what are the different key components of risk management as well. So identification of what kind of risks are available in your application or in your organization, that is the first thing. Then assessing them, what is the vector, what are the depth, breadth of these risks, that is what you need to assess. Then analyzing them, like you need to first know where are they arising, how are they being arised, and what are the measures we can use to control them or to minimize the impact or the damage that is going to be occurring if this particular kind of risk is being exploited, or a threat actor is kind of attacking that particular risk, or vulnerability, let's say. Then mitigation, once we analyze them, we have to design a plan to mitigate them. Mitigate it means like applying some measures due to which this risk that we have or vulnerability that we have should be not exploited, but it could be exploited somehow, but the damage that occurs due to this exploitation should be minimal. So that is why, if you remember, we talked about defense in depth in our previous videos. So if you do not remember it, you can go watch in this particular video about defense in depth. Okay, let's move forward. And now implementation of controls. So in here we discussed what kind of things you can implement, okay, what controls you can implement at what phase. So this is what we get to learn about when we do some risk assessment and analysis, and then we want to mitigate those risks using the controls, that like implement these controls in these phases, and then you are sure to minimize or reduce the risk of this particular application being exploited by someone else. The next principle is about automation. So automation of what? Automation of security testing and compliance checks. So as I mentioned previously, that we need to adhere to some compliance regulatory bodies. Now if we are adhering to that, this thing should be automated. It should not be each time that some person is there who is kind of going and manually checking that, okay, this compliance has been made, this has been made, or this has been made. You need to do it in an automated way. So that is why you need to have a tool to do that. Okay, not just compliance but the security testing as well. Now why do we need to do that? To ensure that security measures are consistently applied and to reduce the manual effort involved in security processes. So that's why I mentioned that we should be integrating some tools in an automated way that would check all these different things. Then next is integration of security tools. As I mentioned in the earlier stages or the phases, that we have to shift left and implement these different tools. So now security practices are embedded throughout the development process, allowing teams to identify and address vulnerabilities early and continuously. So what is the benefit of shifting left? Is to identify and address these vulnerabilities earlier in the development phase, so that the overhead that we will get after the deployment should be less. The threat should be less once the application is live. So what are the examples we just saw in the previous slide? SAST, SCA, DAST, IAC, configuration management tools, and the image and container security. So I guess by now you might have learned this stuff. Okay, don't worry, we will discuss about them in great depth in our further videos, but for now you should be comfortable with this vocabulary by SAST, SCA, DAST, threat actors, governance, risk, mitigation, vulnerabilities, these terminologies. Now once we have done all of these things, we need to deploy the application, and once it is deployed, we need to continuously monitor this particular application to see that if some threat actor is kind of attacking your application, it should not go down, or it should not behave in a certain way, or it should not collapse at all. So that is why continuous monitoring of this application and the security of our infrastructure is really important. So implement continuous monitoring of application and infrastructure to detect vulnerabilities and threats in real time. That is why we need continuous monitoring tools. Alerting systems, logging and monitoring tools is what we usually do or configure in this particular phase. Now why to do this? This allows us for quick responses to security incidents. So as I mentioned, SIEM, security incident and event management. So by using these monitoring tools, we can configure this CM part. So we will again learn this in great detail in another video. But for now, just remember that capturing any security incident is really important. Now you saw a lot of protests are being arising in our country. So these are incidents. But did we capture this beforehand? Obviously no. So that's why we need to monitor the real-time situation of our nation. So okay, that's really dangerous for us. And then we go into a reactive mode instead of being proactive. We should be thinking about security in the first before this incident happened, right? Then what we do, we kind of usually break down on the people, then deploy army or CSF in that particular states or all these areas. So that is why doing continuous monitoring is really important. Now it includes monitoring application logs, network traffics and user behavior. So this is self-explanatory, I think, but I'll still explain this thing in later stuff when we talk about CM. So I'll keep it up to that right now. And the last stuff is feedback loops. Now once we have done all these things, we need to continuously have feedbacks so that we can improve our processes or whatever the response stuff that we do. So to quickly identify issues, share insights and adapt the processes based on real-time data and experiences. So just to improve our procedures, methodologies is what we need this particular feedback loops. Now what it fosters is continuous improvement of our procedures and methodologies, then the rapid responses to issues. Once the issue arises, we can completely focus on that issue and react very rapidly. Then we can make informed decisions, and we can once an incident has occurred, we can do post incident reviews so that we could build strategies that would further safeguard our application or our infrastructures or our entire organization, so to say. So that's what these principles are in terms of DevSecOps. So I guess that's it for our today's video. If you like the explanation, do click on the like button. I hope the like target is 25, so we can achieve it, let's say. So please click on that button. If you see something less than 25 is there on this particular like icon, then share it, share this particular video or this series with someone who you think is kind of trying to learn about security fundamentals and DevSecOps. And I would encourage highly if you subscribe to the channel and propagate this thing in your LinkedIn handles or anything social media you are using. So I guess that's it for now, and you will get the link to this particular slide in the description menu. And that's it for today's video. Let's meet in our next video in order to discuss some more different topic. Let's say, I guess next video is about threat modeling. So see you in the next video. Until then, keep learning and bye bye.